Hello everyone, I am going to explain question number 20 from exercise 4.1 and this question belongs from 11th class maths. Prove the following by using principle of mathematical induction for all and belongs to capital N, means for all natural numbers. So the given mathematical statement is 10 to the power 2n minus 1 plus 1 is divisible by 11. So the principle of mathematical induction is mainly completed in 3 steps. Firstly, we'll assume the statement as Pn, like here I assumed. Let Pn be given statement, and Pn statement is 10 to the power 2n minus 1 plus 1 is divisible by 11. So this statement I assumed as Pn statement. Now this principle of mathematical induction mainly completed in 3 steps. The first step is for n equal to 1, we have to prove Pn statement is true. And then for n equal to k, we have to assume that the pk statement is true. So this you not have to prove. This second step is our assumption. And in third step, with the help of the second step, that is pk statement, with the help of pk statement, we have to bring pk plus 1 statement is true. So by keeping these 3 points in our outline, we are going to solve the question. So we'll start step 1 for n equal to 1. So we'll write here. So we start the step first. Step 1. For n equal to 1, we have P1. So wherever in this Pn statement, wherever n is there, we'll replace it by 1. So we'll get here 10 to the power 2 multiplied by 1 minus 1. Then plus 1, that will give us 10 to the power 2 minus 1 plus 1. Then after its solution we will get 1 plus 1, that is 10 plus 1 is equal to 11. So how we had solved here? First, instead of n I wrote here 1, so 2 1 are 2, then 2 minus 1, we got here 1. So 10 to the power 1 is 10 only, then 10 plus 1 is 11. So we got P1 as 11 and we know that 11 is divisible by 11. So P1 statement is true. So we write down here, since 11 is divisible by 11, so for n equal to 1, Pn is true. Now we'll move to step second. In step second, we'll write down, let pk is true for some natural number k. Then whatever be our Pn statement, in that wherever n is there, we replace it by k. So that will give us pk statement. So pk statement is going to be 10 to the power 2k minus 1 plus 1 is divisible by 11. So you can check your question. So instead of n, I wrote only k, and now we can write it as above statement as 10 to the power 2k minus 1 plus 1 as 11 multiplied by d, where d belongs to some natural number. Because students, here we are concluding that it's divisible by 11. So if it is divisible by 11, then it's your dividend. So dividend is equal to divisor multiplied by quotient. So d is our quotient and d belongs from some natural number. So I hope it's clear to you. So what is the meaning of this line? Once again I am explaining. It's our dividend. Dividend is divisible by 11 means it's our divisor. So in according to the division rule, dividend is equal to divisor multiplied by quotient plus remainder. Since it's divisible by 11, so remainder is 0. So D I assumed as the quotient. So 11D. So it's our equation 1. So we'll assume this as equation 1. Now we'll move to, now this step we not have to prove, it's our assumption only. Now we'll move to step 3rd. Now here we'll write down we wish to prove that pk plus 1 is true whenever pk is true. So in our PM statement, instead of k, instead of n, we are going to replace it by k plus 1. So first I am writing here, since PM statement is 10 to the power 2n minus 1 plus 1 is divisible by 11. So pk plus 1 statement is going to be 10 to the power 2k plus 1 then minus 1 plus 1. So what I have done here is, instead of n in the PM statement, we replace it by k plus 1. Now here I am not writing is divisible by 11 because we have to prove it. It's not available to us. So what sorry for interruption. Here is it divisible by 11 or not is not, we have to prove it. So I am not writing this. Now we have to prove it that it's this statement is divisible by 11. So we'll get here so when we simplify it, we are going to get it as 10 to the power, I am going to open the bracket here, 2k plus 2 minus 1 plus 1, that will give us 10 to the power 2k plus 1 plus 1. Now you already knew one exponent formula, that is a to the power m plus n. If we'll open it, we'll get here a to the power m multiplied by a to the power n. In small 8th class might be you have this formula. So if power are in addition, means you can split it as in multiplication. So here 2k plus 1 is there, so we can split the base. So when we will do it, we are going to get it as 10 to the power 2k multiplied by 10 to the power 1 plus 1. Now what we want is, we want here this equation. I want to create this equation here, that is I want to create 10 2k minus 1. I am just explaining once here. What I want is, I want to create this equation. I want 10 to the power 2k minus 1. So for it, you just see here what I have. I have here 2k. So I am going to divide both the terms by 10 to the power 2. So we will get it as 10 to the power 2k multiplied by 10 plus 1. Both the terms I want to divide by 10 square, and here also 10 square. Since I divided by 10 square, so here I have to multiply also by 10 square to balance it. So it will give us now finally when we solve it, we are going to get here 10 to the power 2k, then plus 1 again I am just writing, then minus 2, then plus 1 upon 100, then multiplied by 100. Now So again I wrote it in the power notation, students. It's in multiply, so plus 1 will come, and it's in divide, so minus 2 came here. Now when we solve it, we are going to get here 10 to the power 2k minus 1 plus 1 upon 100 multiplied by 100. Now I am just writing here equation 1 because I am going to replace something. We have from equation 1, we have 2k minus 1 plus 1 as 11d. It's not 2k, it's 10 to the power 2k minus 1. Now from here, if I want 10 to the power 2k minus 1 only, then it's going to be 11d minus 1. So this replacement I am doing here. Again I am explaining. We want 10 to the power 2k minus 1 value, student, here. So that we'll get from equation 1. This is our equation 1 which we already calculated earlier. So we want only this term, so plus 1 you just shift here, that will give you 11d minus 1. So here instead of this term we have to write down it as 11 minus d. So after replacement we are going to get here 11d minus 1, then plus 1 upon 100 multiplied by 100 as it is. Now I am going to solve this minus 1 and plus 1 upon 100. So we will take LCM here. So we will get here 11d, then we'll take the LCM, plus when we'll take the LCM, 100 is going to be LCM, so minus 100 plus 1 bracket close, big bracket close, multiplied by 100. Now when we simplify it further, we are going to get it as 11d minus 99 upon 100 multiplied by 100. Now we take 11 common from here, because here also 11d and here we have 99. So from both the terms we can take 11 common. So we are going to get it as, when we take 11 common, we are remaining with here d minus 9 upon 100 multiplied by 100. Now since it came in the form of multiple of 11, so if we divide it by 11, it is divisible by 11. So we will write here, thus pk plus 1 is divisible by 11 whenever pk is divisible by 11. So students, in this complete solution, this step is very important, that I am just explaining this. We are multiplying and dividing by 100. So you should know that since we want here in the numerator 2k minus 1, so here plus 1 is already there and we want minus 1, that's why you have to divide it by 2. So when you will divide it by 100, then only minus 2 can come here, and then you will achieve here minus 1. So whatever be the power in the equation 1, same power you have to create here. For that, whatever number you want, by that you just divide, and to balance the equation, multiply by same, so that the equation will be balanced. And then after creating the same term which is available in the equation 1, you just replace the equation 1's replacement like this, and then you just solve by taking LCM, and after taking LCM you will find that both the terms are multiple of 11. So take 11 common, and since this complete term is divisible by 11, because 11 is in multiply, so when you will divide it by 11, it will cancel by 11. That's why we can say that pk plus 1 statement is divisible by 11, but it is only possible if we use the equation 1, means equation 1 means when pk is divisible by 11. That's why I wrote here, thus pk plus 1 is divisible by 11 whenever pk is divisible by 11. So now all three conditions is satisfied. So we'll write down the conclusory statements, that is, hence by principle of mathematical induction, Pn is true for all and belongs to capital N. Hence true. So I hope this question is clear to you. Further, if you have any doubt, you can write in comment and I will try my level best to solve your doubts. Thank you.